I will be dealing with you the biodiversity and ecosystem function. Before I proceed to my topic, let me give you the objectives of my report. Number 1, discuss the concept of biodiversity and its importance. Number 2, cite some threats and possible factors in the conservation of biodiversity. Number 3, discuss the importance and functions of ecosystem. And now, the first thing that we are going to deal is about the biodiversity. But before that, let me share to you the statement of Ed.D that the world is full of magical things, patiently waiting for our eyes to grow sharper. And that is very true, especially nowadays that there are lots of things which haven't discovered yet, but these things really amaze us. And there are at least 40% of the world's economy and 80% of the needs of the poor are derived from biological resources. In addition, the richer the diversity of life, the greater the opportunity for medical discoveries, economic development, and adaptive responses to such challenges as climate change. And of course, the one that we are facing nowadays, the COVID-19 pandemic. On the next slides, I will show to you some pictures, a sort of pictures that you are going to assess. Which one do you like better? Okay, on the first slide, which one do you like better between the picture A and the picture B? Okay, how about on the next slide? Which one is better for you? Picture A or the picture B? And then for the last set of pictures, you have there A or B. So you already selected the pictures that you like. You will know the reasons later behind it. Okay, so let's define now what is biodiversity. You know, the word bio means life, and the word diversity means variety. So in a simple word, biodiversity is the variety of life on Earth and the essential interdependence of all living things. And the scientists have identified more than 13 billion species of organisms. Tens of millions remain unknown. So there are lots of undiscovered species as of the moment. The tremendous variety of life on Earth is made possible by complex interactions among all living things, include microorganisms. So let me share to you the 3 components of biodiversity. Number 1 is the diversity of genes. Examples are the Chihuahuas, the Beagles, and the Rottweilers are all the same species, but they're not the same because there is a variety of their genes. And these 3 are some of the species of the dogs, and they vary from each other because of their genes. And number 2, you have there the component of biodiversity is the diversity of the number of species. For example, the monkeys, dragonflies, and the meadow beauties are all different species. We have the species of plants and the species of animals there. So they are all organisms, however, they are having different species. What is a species? A species is difficult to define exactly. It is a group of morphologically similar creatures which can interbreed to produce fertile offspring and are reproductively isolated. And the third component of biodiversity is the variety of ecosystem. For example, the lakes, the ponds, and rivers are all freshwater ecosystems, while the rocky coast, sand dune, estuary, the salt marsh, coral reef are all marine ecosystems. So what is an ecosystem? Later, you will know further what is an ecosystem all about. But for now, let me give to you a sort of definition of ecosystem. It is a self-contained community of microorganisms, animals, and plants that interact with each other and with their physical environment. So for example, in the illustration, a rock pool. So that is an example of an ecosystem. In that rock pool, you will find there different microorganisms and other organisms living in that particular ecosystem. So based from what we discussed earlier, let me show again a set of pictures, same set of pictures, and you are going to assess which has more biodiversity between the picture A and the picture B. Okay, on the first picture you have there. How about on the picture on the next slide, in the picture A and the picture B, which has more biodiversity? Alright. Okay, the picture B. So all pictures B have more biodiversity. Now, I will share to you the importance or the values of biodiversity. First, biodiversity has intrinsic value, meaning its value to itself. So different species of organisms have their own intrinsic value. Biodiversity has an intrinsic value because that is part of the natural world, and the conservation of species, genetic resources, and ecosystems are important for the maintenance of natural ecological processes. This emphasizes the integrity of ecological communities, nature working as it is, as in representative portions of natural ecosystems preserved in the protected areas, for example, the national parks, the biological reserves, and other categories of conservation units. Next value of biodiversity is the utilitarian value. Utilitarian value is the value something has a means to another's end. We all know that biodiversity can give us goods. Example, sustainable timber. Services, for example, the ecotourism, which we enjoyed a lot. And the last one is for information. For example, the national park wardens. What do we get from biodiversity? Of course, the oxygen, food, clean water, medicine, aesthetics, and the ideas. Should we be concerned about biodiversity as humans? What we know is that the Earth is losing species at an alarming rate as of the moment. Some scientists estimate that as many as 3 species per hour are going extinct, and 20% extinctions occur each year. When species of plants and animals go extinct, many other species are affected, and that is the reality. As we enjoy the different values and importance of biodiversity, we cannot deny the fact that there are also threats to our biodiversity. Most species loss can be traced to 3 major threats. What are they? The habitat destruction, introduced species, and the last one, the overexploitation. Human alteration of habitat is the greatest threat to biodiversity throughout the biosphere. In almost all cases, habitat fragmentation and destruction lead to loss of biodiversity. That's how important human in this world. But it turned out that human activity is the major destruction to our biodiversity. Why we have to be serious on this matter? It's because, number one, there are less than 100,000 plant and animal species lost in last 5 years. Habitat loss is the biggest current threat to biodiversity. Number one reason there is the human activities. The last is the deforestation and forest degradation has increased, meaning the slash and burn process. And we are done on biodiversity, and now let's proceed to ecosystem. So what is an ecosystem? Ecosystem is a population in a community and abiotic factors with which they interact. For example, the marine and the terrestrial ecosystem, in which you can see there in the pictures. And there are some other ecologists who gave their own meaning of ecosystem. According to F.R. Fosberg, that ecosystem is a functioning, interacting system composed of one or more living organisms and their effective environment, both physical and biological. And for R.L. Linderman, the term ecosystem applies to any system composed of physical, chemical, biological processes within a space-time unit of any magnitude. Let's have the term habitat. Habitat is an area where an organism lives, while the niche is the role of or position that an organism has in its environment. For example, in the picture you have there the fish and the coral reef, which serves as the habitat. The ecological niche of an organism depends not only on where it lives but also on what it does. By analogy, it may be said that habitat is the organism's address and the niche is its profession, biologically speaking. A niche is determined by the tolerance limitations of the organism, or the limiting factor. Limiting factor is any biotic or abiotic factor that restricts the existence of the organisms in a specific environment. So these are the factors that may affect in the existence of any organism. What are those limiting factors? You have there the amount of water, which is abiotic, the amount of food, and the temperature, which can really affect the organisms. And these three are very essential for the survival of the organism. Let's now deal the importance of ecosystems. In all ecosystems, green plants are the producer. Green plants maintain equal balance of oxygen and the carbon dioxide. A balanced ecosystem maintains productivity of major areas of land, and the soil fertility can be maintained by ecosystem. Another thing is that floods and droughts balanced by ecosystem. Next, forest, wildlife species, and other natural biotic communities are also maintained by ecosystem. And the biogeochemical cycle are maintained by ecosystem. That's how important the ecosystem. Ecosystem functioning reflects the collective life activities of plants, animals, and microbes and the effects of these activities. For example, the feeding, growing, moving, excreting waste have on the physical and the chemical conditions of their environment. Ecosystem functions, sometimes also referred to the ecosystem processes or ecological processes, are an integral part of biodiversity and can thus be broadly defined as the biological, geochemical, and the physical processes that can take place or occur within an ecosystem. Let's have the processes of ecosystem. So on the picture with the plants, zebra, and the lion, and so forth, illustrates the two main ideas about how ecosystems function. Ecosystems have energy flows, and ecosystems cycle materials. These two processes are linked, but they are not quite the same. You can see there in the figure. So energy enters the biological system as light energy or photons is transformed into chemical energy in organic molecules by cellular processes including photosynthesis and respiration, and ultimately is converted to heat energy. This energy is dissipated, meaning it is lost to the system as heat. Once it is lost, it cannot be recycled. Without the continued input of solar energy, biological systems would quickly shut down. Thus, the Earth is an open system with respect to energy. The controls on ecosystem function. There are two dominant theories of the control of ecosystem. The first, called the top-down control, states that predation and grazing by higher trophic levels on lower trophic levels ultimately controls ecosystem function. For example, if you have an increase in predators, that increase will result in fewer grazers, and that decrease in grazers will result in turn in more primary producers because fewer of them are being eaten by the grazers. Thus, the control of population numbers and overall productivity cascades from the top levels of the food chain down to the bottom trophic level, meaning the highest level, trophic level, will affect the lowest level. The second theory is the bottom-up control, states that it is the nutrient supply to the primary producers that ultimately controls how ecosystem functions. If the nutrient supply is increased, the resulting increase in production of autotrophs is propagated through the food web, and all the other trophic levels will respond to the increased availability of food. For example, the energy and materials will cycle faster. What is an example of the top-down control? Imagine a simplified ecosystem where there are plants, deer, and tigers. The plants are the producers, the deer are the herbivores, and the tigers are the top carnivores. The presence of tigers keep the deer population in check. If there were no tigers in this ecosystem, then the deer population rapidly increased. As a result, all the plants would be eaten. When almost all the plants are eaten by the huge unsustainable population of deer, there is no food left for the deer. So that population of deer would eventually starve to death and the ecosystem would collapse. Meaning, the tiger will affect the deer and the deer will affect the plants, and so on. And the bottom-up control. In the same simplified example, let us consider the reverse scenario. What if the population of plants in the ecosystem dwindled to extremely low numbers? Then the deer would have less food to feed on. Consequently, their population would shrink to reflect the lack of food. When the population of deer decreases, the tigers will also automatically face a shortage of food. The tiger population would also fall. If plants disappeared altogether, then the ecosystem would collapse. Meaning, the major problem first happened at the lowest trophic level. Does an ecosystem have to choose to be either top-down or bottom-up? No. In most ecosystems, studies have shown that this two approaches are not mutually exclusive. For example, in marine ecosystems that were initially thought to be purely bottom-up, there have been periods of top-down control due to extraction of large predators through fishing. That's it for the bottom-up and the top-down control of the ecosystem. So my topic ends there. So what is the application? Biodiversity, the diversity of life on Earth, is essential to the healthy functioning of ecosystems. Habitat loss and overexploitation driven by our rapid population growth are the primary causes of biodiversity loss, which is now happening up to 10,000 times faster than for millions of years before. Conclusion: ecosystem is an important part of environment. Atmospheric, hydrospheric, lithospheric, biospheric, including human, all elements depends on each other. If one element is imbalanced, then whole system will be imbalanced. Nowadays, humans reach an extreme stage of development, and so they can destroy the ecosystem and they can also protect the ecosystem. Just they need to be conscious. They should take proper steps to protect ecosystem for their own protection because they are also an element of ecosystem. Before I end my report, I will share to you this wonderful statement. We are a part of nature, not apart from nature. We have succeeded famously in becoming the technological species, and we are right now. Our survival now depends on our becoming the ecological species and taking our proper place in nature. And for my references, just check out there in the picture or just refer in your handout. Thank you so much for listening. I hope you learned something from my report. God bless.